Assalamualaikum student, and a very good day. This is a video lecture on chapter 4. On this video lecture I'm focusing on DFD only. The rest of the content you can view in another video. This is the textbook that we use as our reference. In the textbook, chapter 4 is represented in chapter 5, data and process modeling. This is the learning objectives of the complete chapter and also the chapter contents. Okay, according to our syllabus, chapter 4 is enterprise modeling, and these are the content of chapter 4. And today we will be focusing on data flow diagram, DFD. Okay, we look at the overall flow of this, the chapters that we are going through. So we are actually looking into chapter 4, enterprise modeling, and enterprise modeling is in system analysis. So today we are going to talk about DFD, meaning that building DFD is a part of phase 2, which is the system analysis. And before this we have seen system planning in chapter 1 and chapter 2. Okay, the learning objective is to look at the symbol, look at the DFD, and the terms leveling and balancing. In this chapter, we will develop a logical model of the proposed system and the document system requirement. The logical model is what does the system do regardless of how it will be implemented physically. So a DFD is an example of a logical model. Okay, model, as we have mentioned before, is a representation of the actual information system. So one graphical technique to build an information system model is to use a DFD, a data flow diagram. DFD shows how data move inside and throughout the information system. DFD provides logical model that shows what the system does and not how it does it. There are 4 basic symbols: a process, a data flow, data source, and entity. Okay, the symbol set that we are using is named GAIN and SASN. Symbols are referenced by using all capital letters for the symbol name. So we look at these 4 symbols as mentioned just now. Process, data flow. Process is a rectangle with a circular border. Data flow with an arrow, data store as shown there, and entity, 3D square. Okay, now we look at the process symbol. The process symbol will can have data input or data output, data input and data output. So the process can be a black box. It does not show the program logic inside the process, but it shows what data comes in and what data goes out. It must have at least one data input and one data output flow. Example of process name: apply, rent, payment, calculate, commission, and so on. The example of a process, the drawing, is shown on this slide. Next, we look at data flow symbol, represent one or more data item. It can be a line with a single or double arrowhead. it goes to a black hole, as we have seen in the previous slide. Gray hole can be produced when insufficient input to generate desired output. Example of names are given here, and example of how you represent a data flow is shown here. Now we look at the data store symbol. It is represented as shown at the bottom of the PowerPoint, a flat rectangle that is open at the right hand side, and the name is as shown here, and it is closely related to entities in ERD. Now we go to the entity symbol. It is a 3D rectangle or square. Yeah. It is also called terminators because they are the data origins and the final destination of data, meaning that when you have data, data must come from an entity or it should end at the entity. Yeah. If the data come from an entity, that particular entity is known as a source. If data finish or ends at one entity, so the entity is called sink. Okay, it can be people or external component of information system. These are examples of DFD, examples of correct combination of data flow and process symbol. You can see the data comes in and goes out of a process. Yeah, data comes in and goes out. The numbers of data flow coming in and going out of a process can differ, as shown in the example. This is an incorrect way to represent a data flow. The first one, you can see there's a process, there's also data flow, but you can see the two data flow in the apply insurance premium, both of them goes out of the process, meaning that the process doesn't have an input, but suddenly it has output. So this is wrong. And in the second one, calculate gross pay, the process just has input but no output, so also incorrect. The third one, it has input and output, but the input and output is not related. Yeah, if you look at the name of the process is calculate grade, so it should receive grades, not date of birth. So if it receive date of birth, it cannot calculate grade and it cannot produce a data called final grade. Yeah, so even though the third example, even though physically you look at it, it is correct, but when you look at the name of the data in the data flow, it is wrongly represented. Okay, moving on. Here are example of data stores and process. Yeah, this is correct. Okay, you can pause the video and look at each one of them. This is incorrect. Okay, the first one, because two data stores cannot be connected by a data flow without a process in the middle. The post-payment process is also incorrect because it has no input data. It just has an output only, and the book flight process, it doesn't have an output data, only input. Okay, this is correct. You can see the data flows between the process and the entity. This is incorrect. You cannot have data flowing from one entity to another, from entity to, or from data store to entity. This is incorrect. Okay, common mistakes in DFD, as we have seen in the previous slides, are also represented in this slide. Okay, now let us look at how to create or draw DFD. Yes, set of graphical model of the information system based on the fact-finding results. So you have to do the fact-finding first, and then you get all the data, then you draw the DFD. So step 1 is drawing context diagram, and then diagram 0, and then lower level diagram. Okay, we look at the context diagram, so that the diagram fits in one page. Use the name of the information system as the process name in the context diagram. Okay. Use unique names within each set of symbols. Okay, do not cross lines. Okay, please read the details given in this slide. Provide a unique name and reference number for each process. Obtain as much user input and feedback as possible so that the model is accurate, and then the user themselves, when they look at the model, they understand because the data information comes from them. Okay, step 1 is to draw a context diagram. Okay, start by placing a single process symbol in the center of the page, and we call it process 0. Identify the entities and the name of the content of the data flow and the direction of the data flow. So this is an example of a context diagram for grading system. So you can see the process is in the middle. The reference number is 0. So we know this is the context diagram. It has only one process, okay, which is process 0. Represents the entire system. So what system is this? You look at the process 0, you know it is a grading system, and this grading system has 3 entities in the grading system, and these are the main data flows within the system. Next is we draw a diagram 0 DFD. Yeah, if you look at the diagram, on the left hand side you have the context diagram for the grading 0. How do you know it is the context diagram? Because context diagram has only one process, and the name of the process is the name of the system, and the number of the one process is 0. And then it's as if you zoom into process 0, then you get diagram 0. Diagram 0 is actually an explosion of process 0. So when you zoom into process 0, you'll get diagram 0, and in diagram 0, yeah, you can see there are more processes, but the entity is still the same number of entity as in the context diagram. Okay. Yeah, as mentioned there, notice that diagram 0 is an expansion of process 0. It has the same number of entity, and also it has the same data flow going to and from the entity. The same entities and the same 6 data flow. Okay, when we are drawing diagram 0, each process in diagram 0 has a reference number. So these are smaller processes. You zoom into process 0, so you get more processes. And for example, here we have diagram 0 for grading system. So we have process 1, process 2, process 3, and process 4 with the names of the process and the number of the process. Okay, the number can identify a series of DFD on its own. Yeah, you can zoom, then you can produce more DFD. If more detail were needed, for example, for establish gradebook, which is process 1, so you will zoom into process 1 and you'll produce diagram 1. Yeah, would be drawn because establish gradebook is process 1. So if you need more detail for process 2, so you will produce diagram 2 because it is based on process 2. Okay. Another highlight here, the final grade data flow output from assigned final grade. Yeah, the data name is final grade. We call it is a diverging data flow because it has one input, but it diverges into two destination, which is a process and a data storage. Okay, leveling a DFD. Yeah, leveling a DFD is a process of drawing a series of increasingly detailed diagram from a general to a more detailed diagram. Also called, so leveling is also called exploding, partitioning, or decomposing. When a DFD is exploded, yeah, or leveled, the higher level diagram is called a child diagram, and the lower diagram is called parent. For example, you have diagram 0 is exploded view of process 0, and then from diagram 0 you will have diagram 1 and so on. Yeah. Step 3 is to draw a lower level diagram. So we have start with a context diagram and then diagram 0, and then we can go lower, yeah, to a more detailed DFD. Yeah, must use leveling and balancing techniques. Leveling example, use a series of increasingly detailed DFDs to describe an information system. Yeah. Okay. Balancing, ensure that the input and output data flow of the parent DFD are maintained on the child DFD. We will look at this after this. Yeah. Drawing DFD, you create diagram 0, which show more detail from the context diagram, and then create lower level DFDs until all processes are identified as single processing function, or we call it functional primitives. So let us take an example of diagram 0, DFD for order system. So we know this is diagram 0. How? Because we look at the number in the process, it is just single number, no decimal number. So this is 1, 2, and 3. So you know this is an explosion from process 0. Yeah. So diagram 0, we have this. Okay, let's say we want to create a lower level DFD from process 1, which is fill order. Yeah, if we look carefully here, fill order, it has two data going out, picking list, and also order reject notice. It has one data flow going in, which is order, and it has connection to warehouse and also customer. Okay, so now we draw diagram 1. Remember why we call it diagram 1? Because it originates from process 1. Yeah, the DFD show details of the fill order process in the order system, and you can see here this is diagram 1. DFD, and you can see diagram 1 DFD, it consists of two entity which has a connection with process 1. And if you look, there's one data flowing into warehouse, and for customer it has one data flowing into it and one data flowing out of customer. Yeah, so these are maintained. Okay, another example, we look still looking at the order system diagram 0 on the top. Yeah, the order system diagram 0 shown at the top of the figure, and it is now we look at diagram 3 of the DFD, which is apply payment. Yeah, just now we look at the fill order, now we look at the apply payment. So we explode diagram 3. So as we have mentioned just now, we explode process 3, which is apply payment. Because we explode process 3, the name of the diagram is diagram 3. Yeah, the name of the diagram reflects the name of the process it comes from. Yeah, so so if we explode process 2, the name of the diagram is diagram 2. So diagram 3, yeah, is exploded from the process 3, and then we know that the two DFD are balanced. Yeah, balanced because, okay, we have the same input and output flows as the parent process. Yeah, we look at process 3, you have payment detail going into accounts receivable, and invoice detail going into apply payment. Yeah, so if you look at the diagram 3, that data flow is also represented there, and then apart from that, there's three other data flow flowing out of apply payment to sales department, bank, and accounting, and they are also represented in diagram 3. So it is balanced. Yeah, all the data flow going out and going in of the process is shown in the exploded diagram 3 DFD. So relationship among the levels of DFD, you can have context diagram. Yeah, remember context diagram in one piece of paper with one only process, and the process is 0, number is 0, and it is in the center, yeah, of the DFD. And then you have level 0, which is excluded from process 0, and then level 1, if you have level 1, it is level 1 is, for example, in this example, the level 1 diagram is diagram 2. Yeah, diagram 2, because it is exploded from process 2. Okay, and then the level, you can have another lower level diagram, which is level 2, and here you can see the level 2 DFD. You can see the number of the process is 2.2.1, 2.2.3, 2.2.2. Yeah, and this explosion come from the process 2.2, yeah, in level 1. So this level 2 is called process 2.2. Yeah, sorry, diagram is called diagram 2.2. Yeah, remember the name of the diagram reflects the number of the process that it comes from. Yeah, okay. This is another example of representation of DFD. Another way to draw DFD. This is the chapter summary regarding DFD. You can read through the chapter summary. And that's the end of the DFD video lecture. Other contents of chapter 4 will be put in Google Classroom in another video. Thank you very much for your time and attention. Assalamualaikum and thank you.